Hey, Algebra 1. We are going to do Brave School. Just a reminder, finish this video all the way through. Answer all the questions. Follow the instructions in the questions. When you are done with this, and you have tried your best at completing the review, this review I'm going to go over, then you will come to my class on either Tuesday or Thursday after school. Make sure you come and talk to me to make sure that I am there available, or talk to your teacher to make sure that you can come. Okay, let's get started. So the first problem, it says Myrna wanted to solve this system by substitution, but Michael wanted to solve it by graphing. We need to show both of them that it does not matter how you solve the system. First of all, it says solve the system. If we're going to solve a system, that means we're going to need to find two things. We're going to find an x, and we're also going to find a y. We're not just going to find one, we're going to find both. Okay? So we need to show, they want to show that, hey, no matter what, if I use substitution, if I graph it down here, or if I use the equal value methods, or if I use elimination, whatever I use, it's all going to have the same answer. And remember, again, when I give my final answer, it needs to be in parentheses. You give the x number or value, and then the y value, or the whatever y is equal to. Okay, so the first one. For substitution, I need to have a letter that is by itself. Here I have y by itself. So if y equals 2x plus 2, then I plug it in to y, because it's equal to y. 2x plus 2 is equal to y, so plug it in for y. And then I'm going to do my work below that. I'll do it down here. So now, let's rewrite this equation. 4x plus 2, and I'm going to plug in 2x plus 2. So if I plug in, remember, write parentheses, and I'm going to plug in 2x plus 2 for y. And notice that I didn't keep y. Y is gone. There's no more y. I only have x in the equation now, because I only want to find x the first time. Now I'm going to draw a line. Helps me stay organized. Now I've got these parentheses, so I need to do these first. And remember, parentheses mean multiply. So now I'm going to have 4x. Let's rewrite that. Plus 2 times 2x, 4x, then 2 times 2, positive 4, equals the same number, 12. Now over here on the left, I have to decide, okay, well, I've got 3 terms here. I've got 3 different numbers. And let's see if I can combine one of them. I have 4x, I have another 4x, and I have this other 4, but it has no x. So if it has no x, I cannot add it. So now I'm going to do 4x plus 4x, which is 8x, and then I still have a 4, and then equals 12. And now remember, I want my variables on the left, and I want the other numbers, or constants, on the right. So letters stay on the left. So here, that means the 8x needs to stay, and the 4 needs to go. And it's positive 4, so that means I need to subtract the 4. And then whatever we do to one side, I do to the other. So I subtract 4 on the other side too. That goes away. All I have is 8x now, equals 12 minus 4, which is 8. And then let's bring the same problem up here so we have more room. All I'm doing is rewriting it one more time. And I remember, I want x by itself, and it's 8 times x. So if it's 8 times x, I need to divide. Okay, and I divide by whatever the number is here. I divide. If it's negative, make sure you divide by a negative. Then divide by 8 again. Again, whatever we do on one side, we do to the other. These 8's cross out. And now x equals 8 divided by 8, which is 1. Great, you found x, but we're still not done. We need to remember, find x and y. So we take this x, and we need to plug it back in to one of these equations. You need to pick the equation that you feel like is the easiest. I think that y equals 2x plus 2 is the easiest because it already has y by itself, and that's what I need to find. So now I'm going to plug in the x wherever there's x. So now remember when we plug in, we write parentheses. And I plug in a 1. Now it's going to be 2 times 1 is 2 plus 2. And then y equals 2 plus 2, which is 4. Great, you found x, now you found y. But we're still not done. Because now you need to write it as a solution, as a point. Or as we say, as some of you guys say in the other classes, as an ordered pair. So now I have the parentheses, and the first number is the x value, which is 1, and the second y value is y, which is 4. And there is my solution. X equals 1 and y equals 4. Now remember, Myrna wanted to solve the system by substitution. Michael wanted to solve it by graphing. And we need to, again, show them that no matter what we do, we're still going to end up with the same answer. So as I work through these problems, I better still end up with 1 and 4. If I don't, I did something wrong. Okay, now we're going to graph these two equations. So the first equation I have is y equals 2x plus 2. The second equation I had was 4x, let me make sure I got it right, plus 2y equals 12. Now remember, in order to graph an equation, I need to put it in y equals mx plus b form, or we call that slope-intercept form. So here I have a slope, and then I have a y-intercept. So I can go ahead and graph that. So let's pick this blue color. We'll do it in blue. So now let's go to our graph. And remember, we start with the starting point, or the y-intercept, which is 2, the second number. So we go up 2. And then our slope is 2, but it's also 2 over 1. So that means that we go up 2, right 1, up 2, right 1, up 2, right 1. And then we want to complete the line, so we go back down the other way. So down 2, left 2. And it looks like I actually have a little bit more space up top. Oops, sorry. So now we go up 2, right 1 over here. And let's go back down the other way. So down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. I'm just going back down the other way. Down 2, left 1. Now I can draw a nice line. Okay. Now let's graph the second line. Now if you look at this, I need it to be y equals, but it's not y equals. So to get y by itself, what we're going to have to do is get rid of this 4x, because we want the y by itself. So let's start by moving the x number to the right side. And we do that by subtracting it. It's positive, so let's subtract it. And if I subtract it from the left, I also need to subtract it from the right. So now the 4x's, they go away. And I have 2y on this side. And now I have 12 and negative 4x. Now if you notice, this number has no x. This number has an x. So we cannot add them. But also we need to remember that with slope-intercept form, we want the x number first and then the intercept second. So we're going to write the negative 4x first. Then the 12 plus 12. Now again, over here on the left, we have a 2. It's still not y equals like our other equation. We still need this y to be by itself. So to get rid of this 2, let's divide by 2. And remember, if I divide by 2 here, I divide by 2 everywhere. I divide by 2 here and here under the 12. So now, after I divide by 2, let's move my line up here. We're going to move ourselves up here. So now we have 2 divided by 2. That goes away. So now we just have y. equals negative 4 over 2, or negative 4 divided by 2. Well, 4 divided by 2 is 2, and negative divided by positive is a negative. And then we write the x, and then we have 12 divided by 2, which is plus 6. So then there is our next equation, y equals negative 2 plus 6. And now that we converted it, the other equation, into the slope-intercept form, now we can actually graph it. So now, this negative 2x plus 6, or starting point, is 6. So let's go up to 6. 1, 2, 3, 4, 5, 6. Start there. And the slope is negative 2, which is also negative 2 over 1. So now negative 2, we go down to right 1, and we put a dot there. Then we go down to right 1 again, down to right 1, down to right 1, down to on right 1, down to right 1, down to right 1, down to right 1. And then we want to make sure we write as many dots as we can, so then we go up to left 1, up to left 1. Okay? So now, make your line. And if you notice, they cross at a certain point. And that is where a solution is. That's where our answer is, right where they cross. So now to find that answer, I go to the x-axis, and it lines up with 1. And I go to the y-axis, and it lines up with 4. So 1, and then 1, 2, 3, 4. So our answer is at 1 and 4. And it should be. It should be 1 and 4, because in the problem before, it was 1 and 4. So now it should still be 1 and 4. So now the question was, down here, for C, what is the point of intersection of the two lines? Well, the point of intersection is where it crosses, and 1 and 4 is where it crosses. Okay? So now, for equal values. For the equal values method, we take those same equations we just made, the y equals 2x plus 2, and we take the y equals negative 2x plus 6, and we set them equal to each other, because it's equal values, so we can set them equal to each other. They're both equal to y, so that means they're both equal. That means I can say 2x plus 2 is equal to negative 2x plus 6. And now we just solve for it. Solve for x. So I'm going to draw my line. And remember, I want my variables on the left and my constants or my numbers on the right. So on the left side, I want the variables, or just the letters. And this 2x, well, that has a letter. This 2 has no letter, so I want that to go. I want it to go to the other side. To do that, I'm going to subtract 2 because it's positive. So then I will also subtract 2 over here. These 2 cancel out. And then I have 6 minus 2, which will be 4. But first, let's write what we have left on the left, which is 2x equals, and then we have negative 2x, and then 6 minus 2, and that's positive 4. Now, here on the right side, again, I want constants, or I want my numbers on the right, and my letters, or my variables, on the left. Numbers on the right, so that means I want this 2x to leave this side, because I only want the numbers on this side. And it's negative, so that means I'm going to add 2x. If I add 2x here, I add it also here. So now this is plus 2x. Now I have 2x plus 2x, which is 4x. And then I have equals negative 2x plus 2x. Well, that just goes away. And then I have 4 over here on the right. So now, again, I want x by itself. So now I divide by whatever the number is, which is 4. And now x equals 4 divided by 4. Well, that goes away. And then 4 over here divided by 4 is 1. But remember, we also need to find the y. So go ahead and take that 1 and plug it into one of your other equations. So I'm going to pick the 2x plus 2, just because it doesn't have any negatives. It looks like the easiest one. And now y equals 2. And if I plug in, remember, right parentheses. So I have a 1. Plug in the 1. Plus 2. Then 2 times 1, well, that's just 2. Then add 2. And then 2 plus 2 is 4. So y equals 4. And again, let's write it out as a solution. So now, or as an ordered pair. And the first number is going to be x, which is 1. And the second number is y, which is 4. Again, 1 and 4. I should end up with the same number each time. And so that means we did it correctly each time. Now in this problem, we have this guy. His name's Ali. And he thinks that the solution to the system, or to these equations, is 1 and 5. So he thinks that x is equal to 1, and he thinks that y is equal to 5. So we need to find out, is he correct or is he incorrect? So we're going to use these two equations down here, x plus 4y equals 21, and 2x plus 3y equals 7, to figure out whether he's right or not. Now we don't have to solve this. We don't have to sit here and find the actual x. We don't need to find y. All you need to do is figure out, does 1 and 5 work for these equations? Are they the actual answer? So to do that, write both equations. So x plus 4y equals 21. And then write the other one, 2x plus 3y equals 7. And then what you're going to do is that the x value, well, is 1, so just plug it in for the x. You're going to plug it in here in this equation, and you're also going to plug it in here on this equation. And then for the y, well, it's 5, so I'm going to plug it in for the y here, and I'm going to plug it in here. So let's go ahead and do that. So now in this first one, I plug in 1, and then here I plug in the 5 for the y. Remember, right parentheses whenever we plug in. And now let's do this side first. Okay, so now we have 1, and it doesn't multiply times anything, so it's just 1. And then we have 4 times 5, so then that's 20. Well, that equals 21. And then 1 plus 20 is 21. So that does work. So for this problem, it's a yes. Okay, it does work. But we can't just check one. You need to check both. Because if it doesn't work for both equations, it's not a solution. It can work for one, but that doesn't mean it's a solution for the whole system, for all of them together. So now over here, I have 2 times x, or 2 times y, 2 times 1, which is x, and then plus 3 times y, or 3 times 5, which is y, and then equals 7. And then, let's move this up, sorry. And then we have 2 times 1, and then 3 times 5 equals 7. And some of you guys are already noticing, oh, this isn't going to work. And then we add the 2 and the 15, we get 17 equals 7. But we all know that 17 does not equal 7, right? So that means that this is a no. It does not work for this equation. So if it doesn't work for both equations, it only works for one, or if it doesn't work for either one, then it means it's not a system. I mean, it's not a solution. So that means Ali is not correct. One and 5 is not the solution. Okay, so now with these problems down here, we're going to be solving by using substitution. You could use graphing. You could use the equal values method that we just did a minute ago. You could do elimination, or elimination where we actually have to change the equation and do some multiplication. So we have to decide as we go through all these problems which is the best one to use. Well, let's look at the first one.
This first one, well, let's take a look at what we have here. The first equation, well, I've got a y by itself, and the next equation has the variables of the letters all on one side. Well, first of all, I noticed that this first equation has y by itself, and I remember from the very first problem we did that in order to do substitution, I needed that variable by itself. So let's go ahead and do substitution then. So I'm just going to write substitution up here, because that's what I'm about to do. And remember, in the end, as you work through all of these problems, we're looking for a solution. We're solving. So that means we need to find an x and a y. Okay, so now, well, I know that x plus 2 is equal to y, so let's plug it in for the y. So let's rewrite our equation. 3x plus 5, and remember, whenever we plug in, we need to write parentheses. And I'm going to plug in the x plus 2. And then that all equals 10. Make sure you write out the entire equation from left to right, everything. Okay, so now, let's take a look. Let's start from left to right. Well, this 3x, well, that doesn't change. That stays the same. And then we have 5 times x plus 2, because remember, a number outside of parentheses means that we're going to multiply it. And here we're going to have to multiply it here and here. So we're going to distribute it. So now it's 5 times x and 5 times 2. So don't forget to multiply both of them. And pay attention to the signs, whether it's positive or negative, because that might change the sign. And equals 10. Now, let's see if we can simplify this left side, because we have 3 different numbers here. Well, here I have a 3x, a 5x, and a 10. Well, I notice that the 10 doesn't have an x, so I cannot add it to these, to either the 3x or the 5x, but the 3x and the 5x, I can add those together. So then that will be 3x plus 5x is 8x, and then we still have a 10, and all equals 10. Now, remember, I want variables on the left, numbers on the right, so I need to get rid of this 10, and I do that by subtracting it because it's positive, so I'm going to subtract 10. And I also do the same over here. Whatever we do to one side, we do to the other. These 10s go away. And guess what? These 10s also cancel out. But that doesn't mean we have nothing. That doesn't mean we don't write anything. It just means that it's equal to 0, because 10 minus 10 is 0. And then we have 8x over here. But we're still not done. So now, as we would with any of these problems on this last step, we would divide by the number next to x, which is 8. So then 0 divided by 8. The 8's cancel out. And any number, anything with 0 divided by any number is equal to 0. So 0 divided by 8 is equal to 0. So x is 0. So let's go ahead and start writing our solution up here, so we can do it as we go. Well, so x is 0, so let's write 0 up here. But we still need to find y, and pick the easy equation. Let's pick y equals x plus 2, and we're going to go ahead and plug in that x to that equation for the x. So now y equals 0 plus 2. Oh, don't forget my parentheses. And then 0 plus 2 is just 2. So then y is equal to 2. So to complete my solution, x is 0 and y is 2. Okay, so let's go over this next one here. So what would be the best method to use here? Well, I've got an x and a y on the left side of the equal sign on the first equation. I also have an x and a y on the left side of this equation. Well, I think the best choice here would be elimination, because I have all my variables in order. They're all lined up. And for elimination, remember, we need to make opposites. I need to have opposites so that I can cancel them out. They have the same number, but different signs. So for example, if I had positive 2, the opposite of positive 2 is negative 2. So I need to have the same number, but different signs. So here, I'm going to change this equation because I want to get rid of x. And if I go down here, I can change this x so that it could be the opposite of 2x. The opposite of 2x is negative 2x. So what would I have to multiply times this x in order for it to equal negative 2? Well, I just multiply negative 2. Okay, so also remember, if I multiply this x times negative 2, I multiply everything by negative 2. So remember that as we go through. So now I have negative 2 times x, which is negative 2x. Then negative 2 times 4y. Well, that becomes negative. And then it's, 8y, 2 times 4. And then 2 times 7 is 14. And it's a negative times a positive, so it's negative. So that equation, we're done with that because we changed it. And what I'm going to do is I'm going to rewrite this equation on the bottom. So I can keep them right on top of each other. Makes it easy to work with. Now, let's draw a line so we can keep ourselves organized. And we have opposites here. We have a negative 2x and then a positive 2x. So if they're opposites, they will cancel out because negative 2 plus 2 is 0. Now, we'll have negative 8 minus 3. And remember, if you're not sure about your negatives and you don't want to make a mistake, take out your calculator and do negative 8 minus 3. And remember that that's y. So negative 8 minus 3 is 11, negative 11, and it's y. And the negative 14 minus 8 is negative 22. And again, in our last step here, we always divide. So we divide by this number next to the y, which is negative 11. These 11s cancel out. And then we end up with y equals 22 over 11. Well, that's 2. Or 22 divided by 11. And then we have a negative times, or divided by a negative, so that's positive. So it's just y equals positive 2. But now we still need x. And I think I'm going to use the second equation. That looks the best to me. But you can choose. If you want to use the first equation, you can do the first equation. I just noticed that this one doesn't have any negatives, so it looks easier to me. So y equals 2, so plug it into the y, not the x. So now let's rewrite the equation. And remember, when we plug in, write parentheses. Helps us remember that we might have to multiply. And then all equals 7. And we can do the line here as well. Now we have x. Well, that doesn't change, at least in this step. And then 4 times 2, well, that's 8, equals 7. And remember, we want x by itself, so they'll have to get rid of this 8 on this side. I'll subtract 8. I do it to this side and this side. That cancels out. And now we were left with x. And then we have 7 minus 8, which is negative 1. So x is equal to negative 1. And then let's write our solution as the last step. Well, the first number will be x, which is negative 1. And our second number will be 2, which is y. Okay. Now let's go to B. Okay, so now for this problem, well, it looks like my variables are lined up. I have x and y, and then numbers and numbers. But I don't have any opposites, so I'm going to have to make opposites. So how could I multiply these so that I could get opposites? Well, let's see. If I multiply the 4 times something, well, the 4 is too big. It's bigger than the 2, so I'd actually have to divide. I don't want to divide, I want to multiply. Well, the 2 is smaller than this 3. So is there anything I can multiply times this 2 to give me equal 3? Oh, no, I can't do that. That's a fraction. All right, well, let's go to the next equation. Is there anything I can multiply times this 2 to be the opposite of 4? Yeah, I could do that. So let's just change this second equation. And what do I need? And I need to get the opposite of 4x. Well, opposite of 4x is negative 4x. So what do I multiply times 2x to get negative 4x? Well, that'd just be negative 2. And remember, multiply everything in that equation. So now negative 2 times 2 is negative 4, but also times x. And now 2 times 3 is 6, and times y. And we did a negative times a negative, so it's positive. And then 10 times 2 is 20, but then it's a negative times a positive, so that becomes negative. So I'm done with that equation. Then let's go ahead and rewrite the first equation. Let's bring it down and rewrite it so that we can line it up nicely. Okay, so now negative 4x and 4x are opposites. That's what we just made, so those cancel out. And I also notice that I have negative 20 and positive 20, so those will cancel out and equal 0. So now on the left side, I'm left with, let me draw my line, 6y plus 2y, well, that's 8y. And then this negative 20 plus 20 is going to be equal to 0. So now let's go ahead and divide by 8, divide by the number next to the variable, or next to the letter. That cancels out. So then we have y on this side. And then 0 divided by 8, or 0 divided by any number, is just 0. So now let's go ahead and start writing our solution. And remember, our first letter we found was y. So we're going to write in the second number, 0, because it's y. And then let's pick an equation, and I'll pick the top one because it doesn't have any negatives. And then let's go ahead and plug in that 0 wherever there's a y, because 0 is equal to y, so plug it in for y. So now we have 4x plus 2 parentheses times 0 equals 20. Okay, so now the 4x doesn't change in this step. Now we have 2 times 0. Well, that's just equal to 0. And then let's see, 4x plus 0. Well, that's just 0. So now we have one number on each side, so now we can divide. And we divide by the number next to x. So now we just divide by 4 on both sides. And then we get this to cancel out. And then we get 20 divided by 4. Well, that's 5. So then our x value ends up being 5. Okay, so let's go over to D. Okay, so now, in this case, I have one equation that has y by itself and another equation that has y by itself. Well, the last time I had a problem like that was if I go back up to the first page and I go over here to exclude the equal values method. Well, we had an equation where it was y equals, or y by itself, and y equals by itself, and then we set them equal to each other. Okay, so let's go ahead and do that. Okay, so anytime we have two equations where they both have letters by themselves, we'll take the other side and set it equal. So now I take the negative 2x minus 3, and I set it equal to x plus 3, because they're both equal to y. So that means that this y is equal to this y, which also means that this is equal to this. So I can just set it equal and solve. So let's draw the line. Okay, so now you guys are going to work on this problem. So work on this problem, put your answer on both on your worksheet, and you're going to type it in on Edpuzzle, and then I'll show you how to do this problem after you answer it. So just remember, on this problem, I could choose to eliminate x, or I could choose to eliminate y. They're both set up so I could probably eliminate either one. Well, if I was to eliminate x, well, I need this x down here to be the negative 4x, so I just multiply it times negative 4. But I decided that I'm going to eliminate y, because y and y are both the same number already, but just one of them needs to be negative. So if I multiply everything times a negative 1, well then that makes everything negative. And so that's what I did here. Okay, so here's the whole problem worked out. You can kind of pause it here if you want to look over and see if you made a mistake somewhere. Also, just remember, if you want to check your answer, you can just take these numbers and plug it back into these equations and see if they work. So if I plug in 1 to the x and negative 4 to the y, well then 1 plus the y, or say 1 plus negative 4 should equal negative 3. And it does. And if I plug in 1 here to the x on the first equation and negative 4 to the y in this first equation as well, let's see, that's 4 times 1. And then minus 4. Well, 4 minus 4 is 0. So these answers are correct. And that's how you can check it in. So just go ahead and plug it back into your original equation to check your answer. Okay, let's go over to F. Okay, so now on F, well, let's see. I see that the numbers on the top are negative, and then these are positive. So I won't have to multiply it a negative because they're already opposite signs. But now I need the same number. Well, the numbers on the top are smaller, so I'll probably want to change the top equation so that they can be the same number here. Well, if let's look at the x. I can make this 3x to be 6x by multiplying it times 2. Okay, so let's multiply everything times 2. So now 2 times negative 3x, well, it's negative 6x. And 2 times negative 4, y is negative 8y. And then 2 times 6 is 12. Well, looky here. Well, 6 minus 6, well, that goes away. And 8y minus 8y, oh, wait, that goes away too. I don't have any more letters left. There's no more variables. So the left side, if they both cross out, all I have is 0. Okay, well, let's not stop there. Let's make sure we work out the rest, just in case. Okay, so now we have negative 18 plus 12. Well, that's equal to negative 6. But wait a minute. 0 equal to negative 6? That's not right. That's not even true. 0 isn't equal to negative 6. So if you end up with two numbers and they're not equal, that means there is no solution. So in this case, there is no solution. If you end up with a 0 on the side and a 0 on this side, well, 0 is equal to 0. That case, it could be any number, or all real numbers is what we would write. So for this problem, this is not the answer, all real numbers. But let's just say that it was 0 equal to 0. In other words, this canceled out, the x's, the y's canceled out, and your numbers canceled out. If that is the case, they all cancel out, and you have 0 equals 0, well then your answer would be all real numbers. But for this problem, only the letters canceled out, but the numbers, we still had some numbers left, and it's not equal, so that means this is our answer, no solution. Okay? Now, with these problems, we're given an answer. We're given a solution. So for this equation, we were given x equals negative 4. We don't have to go finding x. We don't have to go and find x because we're already given this x here. But what we need to do is determine if this is actually a solution, if it's the actual correct answer. Okay, so what you're going to do is simply just plug it into wherever there's x. And as long as it's correct at the end, then it's the right answer. Okay, so let's go ahead and plug in negative 4 to the x here. Let's write parentheses. So now negative 4. And then write the rest. Well, we have minus 2 equals 2 parentheses, negative 4 again, plus 2. Okay, so let's go ahead and work all this out. So now we have 3 times 4, well that's 12, and it's positive times a negative, so it's negative, minus 2. And then 2 times 4, well, that's 8, and it's another positive times a negative, so that's negative, and then plus 2. Okay, so now I have negative 12 minus 2, well, that's negative 14. And then negative 8 plus 2, well, that's negative 6. Well, that doesn't work. Negative 14 is not equal to negative 6. So if it's not equal, then it's a no. Okay, so negative 4 is not the solution. There is a solution, but negative 4 is not the solution. So I can simply just write no. Or sometimes in my class, they just write X. All right, and then for a correct answer, they'll put a check. Okay, so let's go into the next one. B. Okay, so let's go ahead and plug in 21. Okay, so now we're going to have parentheses and 21 minus 11 is less than or equal to negative 32. I want you to work that out and figure out, is it a yes or no? Well, after plugging in 21, well, it's 21 minus 11, and that equals 10. But it's an inequality, so we can, even though the numbers are different, it still might be true. So this says x, it says 10 is less than or equal to negative 32. Well, is positive 10 smaller than negative 32? No, positive numbers are always bigger than negative numbers. So this, and it's not equal either. So this is a no. It's not true. Okay? So that's not the answer. All right, now with this one, we not only have an x to plug in, now we also have a y. So same thing, but now we're just plugging in two different numbers. So now we have negative 1 over 3, and then remember when we plug in we put parentheses, okay, and we have negative 6, and then plus 2 parentheses, because we're also plugging in the y, and it's 1, and that equals 4. Okay, so we are multiplying here a fraction, 1 over 3, times negative 6. Well, in order to multiply fractions, what I need to do is make this a fraction. So I can just put the 6 over 1, and then just multiply across. Now it's the top numbers multiplied and the bottom numbers multiplied. But what I want to do here first, to make sure I do this correctly, is consider that there's two negatives here. Okay, so in the end, make sure we're paying attention to that. So now let's do the top, 1 times 6, the numerator, well, that's just 6, and then the bottom, 3 times 1, well, that's 3. And then I have a negative number times another negative number, so we know it's just positive. Okay? And then we have 2 times 1, which is 2, equal to 4. Oops. Now let's just move ourselves up here. Well, let's see, 6 divided by 3, well, that's 2. And then add the 2 as well. Oops, sorry, not plus. Equals 4. And then 2 plus 2 is 4. And that all equals 4. So this is a correct answer. That is good to go. Or it's a yes. Because 4 is equal to 4. So that means negative 6 and 1 is a solution for this equation. Okay? Or if I was to graph this, change this equation into a line, this point would actually touch the line. Okay, now I want you guys to do this one on your own. Okay, so after I worked it out, I got negative 1 is less than or equal to 8, and negative 1 is less than positive 8, so this is a yes. Now one thing to pay attention to is, remember, every time you plug in, write the parentheses, because in this case, I had a negative next to the x, so that negative still stays next to the parentheses, because I plugged in a negative number, and I still have and I also have a negative out here. So that means these two negatives will become positive here. So make sure you pay attention to that when you're plugging in. Okay, so let's go back. Let's go down here. Okay, this is on the next page. Okay, so now, again, we're dealing with inequalities. Okay, inequalities, anytime we have a less than sign or a greater than sign or a less than or equal to sign or a greater than or equal to sign. Okay, so given this inequality, which says x is greater than or equal to -5, question is, what is the boundary point? Okay, the boundary point is simply whatever this number is. That's telling us our limit, or the point that tells us how far we can go. So that point is just simply the number that is in your inequality. So it's -5. And the second question it says is it included in the solution? Is -5 actually part of the solution? Can it be an answer? Can it be a part of the solution? Well, the answer to that depends on what sign you have. If you have a less than sign, such as this or this, your number is not a part of the solution. So not part of the solution. And if your sign is a less than or equal to, remember the difference is this equal line here. If it has an equal line there, then that means that it can be part of the solution. You say is part of the solution. Well, let's look at our inequality that we're dealing with. Well, this one does have an equal sign at the bottom. It's greater than or equal. So if it is equal, then that means that -5 is part of the solution. Okay. Now we got to go over here and graph it. So here we are. We have our boundary point of -5, so we're going to go ahead and start with that. Now if we have a less than or greater than sign, you're going to draw an open circle. If you have a less than or equal to, or a greater than or equal to, you're going to draw a closed circle. So here we need to draw a closed circle because it's greater than or equal to. And now it says that x is greater, meaning that x is more positive than -5, so we're going to shade all the way to the right. Okay? And then that will be it for graphing it. Now for C, it says name 2 possible solutions to this inequality. Well, any possible solution is a number that is somewhere in this shaded area. Okay, and obviously the shaded area keeps on going forever and ever. But all you have to do is pick a number that's in your shaded area. So let's see, let me pick -1. And I'll pick 5. Well, just to double check to make sure it is a solution, and to make sure it actually did the graph correctly, let's plug in that -1 and that 5 into the original inequality. Okay, so now -1 for x, so now it's -1 is greater than or equal to -5. Is that true? Yes, -1 is bigger. Okay, so that one works. Then same here. 5, is that greater than or equal to -5? Yes, it is bigger. So then yes, these 2 solutions work. Okay, so those are 2 possible solutions I could choose. Okay, so now we're going to solve the inequalities. So we're going to solve these inequalities and then graph them. Because we can't just graph this inequality. It needs to have x by itself. Something like this. Kind of like our last problem where x was by itself. Okay? But x isn't by itself, so we need to change the equation so it is by itself. And then we need to make sure we test a point to see if our solution is the right one or see if it's correct. Okay, so let's go ahead and start that. So you approach this just like you would if you're solving any equation. Okay, so here we want the x's on the left, or the letters on the left. So we need this 5 to go away. So let's add 5 here, and then add 5 here as well. And then these 5's cancel out. And then we have just 4x left over here. And then write your inequality sign, which is less than. And then we have -21 plus 5 And if you're not sure what that is, check on your calculator. Well, that's negative 16. And then we still have a 4 next to this x, so we need that to go. So in order to get rid of that 4, we divide. Those 4's cancel out. And then we get x is less than, remember we keep writing the same sign, 16 divided by 4, well that's 4. And then you have a negative divided by positive, so negative 4. And so let's go ahead and graph that now. So now, x is less than negative 4, so let's start with the boundary point, negative 4. And it says less than, not equal to, but just less than. So that means we're going to have an open dot, or an open circle. And x is less, so that means x is more negative, and negative is in this direction to the left. So we shade to the left. Okay, and now we need to, remember, pick a test point to make sure that our solution's good. Okay, so let's go ahead and pick a point somewhere in this shade. I'll pick negative 8 and plug it in. And then we say to ourselves, is negative 8 less than negative 4? Yes, it is. Because as we go in the more and more negative direction, those numbers kind of get bigger. But they are considered smaller because they're more negative. Okay, so that does work. Okay, so let's go over here. Now, this one, we still approach it the same way, but the last step is a little bit different. So let's go ahead and get rid of that 4, because we don't want numbers on that side. And do the same thing over here. And now, let's zoom up a little bit. So that 4 cancels out. And then we just have negative 3x less than or equal to 25 minus 4. Well, that's 21. And then the last step is divide by that number next to x. Well, it's negative 3. Okay, so now these negative 3's cancel out. And then we have x is greater than or equal. So if you notice, the sign flipped. It changed. Anytime we divide by a negative number, if we end up dividing by a negative number, this sign needs to flip around and change. Okay, so make sure that changes. Only when we divide by negative, though. Okay, so now 21 divided by 3 is 7, and it's positive divided by negative, so it's negative. So going back to this problem, the last number we divided by was a positive 4. So the sign did not change. It stayed the same. Whereas here, we divided by a negative number, so the sign does flip. Okay? So make sure we do that. Now, let's graph it. Well, we have negative 7. Well, sorry, x is greater than or equal to negative 7. So let's start with our boundary point. And it's equal to, so we're going to do a closed dot. And it says x is greater than, so that means we're going to shade in the more positive direction to the right. Got lots of shading to do. There we go. And then go ahead and pick a test point. Any point that's somewhere in your shaded area. Let's pick 3. And then we say, is 3 greater than or equal to negative 7? Yes, it is, because any positive number is always bigger than a negative number. Okay, so now this says write the inequality that represents all real numbers greater than or equal to 8. Well, let's look at this one step at a time. Well, all real numbers, anytime you see that, we mean x. And then we have greater than or equal to, well, that just means greater than or equal to, the sign. And then the last number is 8. So that's how you do those. Remember, all real numbers is x. And then if it says greater than or equal to, we'll put the greater symbol. If it says less than or equal to, obviously you're going to put the less than symbol and equal to. Or it might just say less than, and it's just that. Or it might just say greater than, and it's just that. So pay attention to what that says. And that's it. Okay, so let's do some graphing. Okay, so now with this one, we are going to take this point and we're going to figure out, is it a solution for these equations, for this equation and this inequality? Because the question says, is the point 4 and negative 4 a solution for the following, this equation and this inequality? So what we need to do is graph the equation and the inequality and the point to prove whether our solution is right or not. Okay? So we need to graph the point as well. So let's go through that. So first, if we remember how to graph y equals, or how to graph any equation, we start with our y-intercept. And then we look at our slope, which is 1 over 2. So that means we go up 1, right 2. Up 1, right 2. Up 1, right 2. And then go back down the other way. Down 1, left 2. Down 1, left 2. Down 1, left 2. And then go ahead and draw a line. Now let's go ahead and graph that point. So now 4 is here on the x-axis. And then let's go to the y-axis. And negative 4 is here. And let's actually do it in a different color. My line disappeared. I hate it when it does that. There we go. Let's do a different color. Let's pick, I don't know, pink. Okay, so here's positive 4, and then here's negative 4. Well, that lines up right there. So there's the point 4 and negative 4. Well, when we have an equation or an equal sign, it's a solution, that point is a solution if and only if it touches the line. And our point does not touch the line. So it is not a solution because it doesn't touch the line. Okay? Now let's take a look at this one over here on the right. Graphing is similar, but just a little bit different. Now in this case, the difference is that we have an inequality sign. We have a less than sign. Okay? So now let's start by graphing our points. Well, again, we start with the same thing, negative 4, and we go up 1, right 1, up 1, right, up 1, right 2, not 1, up 1, right 2, and then do the same thing, go down 1, left 2, down 1, left 2. And now, before you draw your line, you need to pay attention to what is that sign there. If the sign is less than or greater than, you're going to draw a dashed line. And if it is equal, less than or equal, or greater than or equal, you're going to draw a solid straight line. Okay? So this is just less than. There's no equal to sign. So now it's going to be a dashed line. And then the second thing we need to include is that if it is greater than, we shade above the line. And if it is less than, we shade below the line. Well, in this case, it's less than. And it doesn't matter whether it's equal to or not. If it's greater than, you shade above. And if it's less than or equal to, then you still shade below. Okay, so this one is less than. So that means it's y is less than, so that means I shade below the line. In other words, if I have a point inside that shade, it is a solution to this inequality. And you could also, let me put my webcam on here for a second. You could also use the thumbs up technique. If you take your thumb, if it says greater than, let me zoom out so you can see me. If it says greater than, you have a thumbs up. And that means you're pointing up, so you shade above the line. If it's less than, it's thumbs down. And and my thumb is pointing down, so I shade below the line. Okay?
Good afternoon, grades.
So
February 24, 2006.
So let's go ahead and graph that point. 4 and negative 4 and check to see if it's a solution. Again, x is 4, so on the x-axis it's 4, and then y is negative 4, and that lines up right here. And guess what? It is right in the shade, so that means that for this inequality, for this problem, it is a solution. So we could say it is a solution because it is in the shade.